Alright people, so what we're doing today, multiplying radicals. Now let's get into how we multiply radicals. So of course I'm going to give you a couple steps. Multiplying radicals, multiply numbers on the outside with other numbers on the outside of the radical. So outside with outside, and then the next step is multiply the radicands with other radicands. That would be inside times the inside. That's the ones underneath the square root. Simplify if possible. So let's go through a couple examples. This one I think is very straightforward, but it can get kind of confusing. So first thing before we get into this, if you have not watched Simplifying Radicals, this is what you need to watch that first before you watch this. Okay? So just giving you the heads up. So first thing first, we multiply the outside times the outside. So that would be 2 times 3 will give me 6, and what's inside would be 60. Now let's break this down, which would be, so let's break down the 60, which would be 6 and 10. Now I can break that down again to 2 and 3. I'm going to cross that out because I'm really done with it, right? Now I'll also break this one down to 2 and 5, and I'm going to cross that out because I'm done with it because I've already reduced it. Now it's down to its prime numbers. So now if I have a pair of anything, I'm going to put it on the outside. I have a pair of 2's. So that would be 6 times 2, and what's left over that does not have a pair would be 3 times 5, which gives me 12 root 15. Okay? So this is my answer. Alright? So multiply and simplify. Close that out. Let's try example 2. Now, same thing with this one. Multiply, then simplify if possible. So first thing we're going to do, multiply the outside, I get 15. Multiply the inside with the inside, I get 63. Same concept as I did before, 15. Break this down, it would be 9 and 7. The 9 and 7 can be broken down into 3 and 3, and I have 7 left over. If I have a pair of these, I'm going to put this on, bring it on the outside. So that would be 15 times 3, right? And what's left over? Just my 7. So square root of 7. So 15 times 3 gives me 45. Square root of 7. And that's my answer for that one. Alright? 45 root 7. That one's pretty straightforward as well. Now, our next one is a little different, but I think if based on how I show you, what I show you how to do with this, when I show you how to do this, you'll be basically fine. So, same concept, but the only thing that's different is I have a little parentheses right here. So to multiply this times this and this times that, I'm going to distribute it in. So you want to distribute. So we get 7, well actually not even 7, because 7 times 4, I can't multiply the 4 times the 2, I can only multiply the 4 times the 7, which actually gives me a 28 root 4, right? When I distribute this into here, and this was for that one, right? When I distribute this one into here, I only can multiply what's underneath the radical times what's also underneath the radical, which gives me 7 root 6. So as you see here, I can't do anything more to this. I can only leave it alone. Later on, we're going to talk about adding and subtracting, so that will be in the next video that you want to look at. So you make sure, but as of what we know right now, you just leave it like it is. So that's a 7 root 6. Alright? Next, let's jump into dividing. Now dividing has a couple more steps. A couple little more things that you need to know. So let's first talk in, what do you need to know? Check and see if you can simplify the radicands and split them up. Simplify perfect squares. If there is a radical in the denominator, rationalize it. Check again to see if there are any numbers outside the radical, and then if so, simplify. So, but one key thing that you really need to pay attention to is this word right here, rationalize. So let me go through an example on what's rationalized and how we use it. So rationalize. Rationalizing only works for the denominator. So you multiply the top and the bottom by the bottom radical, the bottom one. Simplify the top. The bottom will become the radicand. What I mean by that, when you're multiplying a radical times a radical, it'll actually become the number underneath the radical. And let me show you what I mean by that. So, in this is the first example. Now, in this example, we don't have a radical in the denominator. We just have 16 divided by 8. So the easiest thing to do is, can 16 divide into 8? Yeah, let's go ahead and just divide it. So if you see here, reduce the fraction first. So 16 divided by 8, and then 8 divided by 8, I get basically, well, which is square root of 2, which is just 16 divided by 8 just turns into 2, so square root of 2. That's all you gotta do for this one. Now the next one, do we have a radical denominator? Yes. So what we need to do, multiply times the radical in the denominator. So what do I multiply by? Square root of 5 times the top and the bottom, which is, if you notice, square root of 5 times square root of 5 is really just 1. So now if I multiply the square root of 5 times square root of 5, what do I get? I get 25. Now I multiply the square root of 3 times 5, I get 15. Now can I reduce 15 down anymore? No, it'll just be 3 and 5. Can't break it down anymore. Can I reduce the square root of 25? Yeah, I can reduce it. It becomes just 5. And then you'll end up with the answer of square root of 5, square root of 15 over 5. Alright? So this is basically the beginning step on how to rationalize the denominator. As you see here, multiply the denominator times the denominator, and I'll end up with basically the radicand. So as I said, 5, 5, you see the pattern here? Alright, so let's go through another example. This one right here, so 6 square root of 3. So what I'm going to do in this situation is, I have a radical denominator, so what I need to do, rationalize it. So I'll multiply the bottom times square root of 3, multiply the top times square root of 3, and I end with 6 root 3 over square root of 3 times square root of 3 is, as we said, would just be 3, right? Now, if I break this down, 6 divided by 3, what do I get? I get basically 2 square root of 3 over 1. And all I did there was divide by 3, divide by 3. So 6 divided by 3 is just 2, 3 divided by 3 is just 1. And my answer is 2 root 3. Okay? Here we go. And as you see, 2 root 3. Now, this one. Now this one has a couple more steps than we've been doing, but as you see, it brings everything together. So the first thing is I don't have a radical denominator, so I don't have to worry about it. But what can we do? We have to divide by something. So what can I divide by first? What I can divide by is 9, right? Divide this one by 9, divide this one by 9. And what I get is the square root of 45 divided by 9 is 5. 9 divided by 63 is 7. Now I can break this down a little more, and that would be square root of 5 over square root of 7. Now as you see right here, what can I do? I have a radical in the denominator, so what I need to do? Rationalize it. So I need to multiply this times square root of 7 times square root of 7, and I end up with square root of 35 over square root of 7. And as you see here, I can't break this down to 35 anymore because, why not? Because it's just be just 5 and 7. And I can't do anything with that. So this would be your answer right here. Alright? Now let's go over one more example and that will be it. One last example. 27 over 48. Same concept. What can I do in this one? Divide by what? I'm going to divide by 3. Right? Yeah, and I'll get 9 over, and let's just want to make sure, what's 48 divided by 3? This one's 16. No. Yeah, 16. So I'll get square root of 9 over square root of 16, and that we broke it down into square root of 9 over square root of 16, which would just be square root of 9 is just 3 over 4. Alright? So as you see, here we go. Pretty simple, pretty straightforward. We've gone over almost every basic concept. Now if you have any more questions for any of the questions that you might need with the examples, please come and ask me, Ms. Black, or Ms. Glover, or Coach Bryant. good one. Later.